Hi guys, welcome to Sri Lanka's Developer Forum July meeting. And today we have Sugandika with us. She'll be talking on she will be talking on yeah she she'll be talking on developing microservices with .NET, microservices with Entity Framework Core as well. Sugandhika has like 10 years of experience in similar areas, C Sharp, .NET, and JavaScript, and she's introducing herself. And she's working as an associate tech lead, Embla Software Innovation. And Sugandhika, you can just take it over. It's over to you.
Okay. Okay. Thank you, Fitri. Yeah. Hi. Good evening, everybody. Today we are going to discuss about developing microservices with .NET Core and EF Core. Firstly, let's have an introduction to microservices. What are microservices? Microservices are also known as microservice architecture. It is an architectural style that structures an application as a collection of services. If we consider a particular collection of services, each service has a specific set of features. What are those features? Let's have a look at them. Microservices are highly maintainable and testable. It is very easy to maintain a microservice and testing can be done independently from other microservices. And they are loosely coupled. If we consider a set of microservices, it is very easy to replace a specific microservice without affecting the other services. And microservices are independently deployable. If there is a change in a specific microservice, we can do that change and deploy that microservice independently. So we don't need to deploy all the microservices together. And they are organized around business capabilities. And also microservices are owned by a small team. So it's very easy to manage few small development teams rather than one big development team. There is no specific hard and fast definition for microservices, but I found this definition in martinfowler.com. According to Martin Fowler, microservices can be explained as a particular way of designing software applications as suites of independently deployable services. And while there is no precise definition, but it explains about the architectural style and common characteristics around organization, around business capabilities, automated deployment, and then intelligence in the endpoints and decentralized control of languages and data. In order to identify the advantages of microservice architecture, let's do a quick comparison of microservices with monolithic architecture. So if we start with the traditional monolithic architecture, here I have added this image explaining an example traditional web application architecture. So starting with the browser, here this is the starting from the browser, here we can see the database, and inside the single component everything resides together. That is the UI, the services and everything. The account service, inventory service, shipping service, all the services along with the UI resides together. That means the front end, the business logic, data layers, everything resides together. So in a way, the monolithic architecture is simple to develop, test, deploy and scale. Now let's move on towards the microservice architecture. There is a sample diagram added here representing the microservice architecture. So let's imagine that this is an e-commerce application. So we are building an e-commerce application. It has a web client and also a mobile client. And the application takes orders from customers, verifies the inventory and available credit, and then does the shipment. So the application consists of several components, including some backend services here. Those backend services can be used for checking credit, maintaining inventory, shipping the orders, and so on. As I mentioned earlier, the application consists of set of services so that we can break down these services in our e-commerce application as order service, payment service, inventory service, credit service, and so on. And you can see if a user tries to communicate with these services via a mobile client or web client, the communication is done. The request passes through the API gateway and then reaches the particular service. That means all the communication of the microservices passes through the API gateway. So why do we need an API gateway here? There are some advantages of using an API gateway. API gateway adds an additional layer of security to our microservices. And also it enables support for mixing communication protocols. And it prevents exposing internal concerns for the external clients. And also API gateway helps us to decrease the microservice complexity. That means by default the microservices address the implementation addresses token-based authentication and so on. So if assume this is the order service, and if the order service is trying to focus on token-based authentication and also managing the orders, then that implementation would be too complicated. So that we can let API gateway to take all the responsibilities related to token-based authorization, authentication, and such kind of security related responsibilities, whereas order service can handle his own responsibilities such as managing orders, deleting orders, and so on. So that is an added advantage of API gateway. And also API gateways are helpful when it comes to microservice mocking and virtualization. And if we consider these microservices, they are built based on the main functionalities and also some of the major entities of the e-commerce application. And also each microservice has its own database, and they act as a single or isolate individual components. And the communication starting from the front-end clients, communication to the services via API gateway, and also the communication between the services, internal communication is implemented as REST API calls. And also in case there is a need of internal communication, such as order service needs to communicate with the inventory service. In that situations, we can implement a messaging broker or message broker. So there are some additional advantages of implementing a message broker as well. Message broker provides communication between services that may not be running at the same time. And also it improves the system performance by introducing asynchronous processing. And message broker increases the reliability by guaranteeing that the transmission of messages. So this is a basic explanation about microservice architecture. Let's do a comparison of monolithic architecture and microservices. Yeah. In this diagram, you can see this is a sample diagram. On the left hand side, we have a we have an example of monolithic architecture, and on the right hand side we have an example of microservices. So starting from the left hand side, the monolithic architecture, according to this diagram you can see all the components, the UI, business logic and data access layer, everything resides together, and they are tightly coupled as a single component, and this component is connected to a single database. And if we consider, in contrast, if we consider the microservice architecture, the UI is separated from the services, and services are hosted independently, implemented independently, and each service has its own database. So this is the microservice architecture. So starting from the monolithic architecture is better when the application is smaller because it's simple to develop. We can use current development tools and IDEs to support the development of monolithic applications. And it is simple to deploy as well. And also it's simple to scale. We can scale the application by running multiple copies of the application behind a load balancer. But when the application becomes larger, this will be very difficult to maintain because there will be difficulties of managing large teams, and also there are some difficulties of continuous development. Scaling the application can also be difficult because it can be scaled only towards one dimension, and it requires a long-term commitment to a technology stack. Or, in other words, monolithic architecture forces you to get married to a certain technology stack you choose at the beginning of the development. And in some cases, we have to stick to a particular version of that technology, which is even worse. So it is very difficult to switch the technology stack in the middle. And if we have a look at the microservices architecture, microservices are highly maintainable and testable. So it enables rapid and frequent development and deployment. And microservices are loosely coupled with other services. So it enables a team to work independently on their service without affecting the other services or without being impacted by other services. And they are independently deployable. So a team can deploy their own service without having to coordinate with other teams. And also it is capable to being developed by a smaller team. And it's essential for high productivity by avoiding the high communication overhead of large teams. As I said earlier, it is always easy to manage few small teams rather than one big development team. So far, we have discussed about microservices and their advantages of microservices over monolithic architecture. So let's discuss about the advantages of .NET Core when it comes to developing microservices. So here are the advantages of .NET Core listed by me. .NET Core supports cross-platform needs. We use .NET Core when the application needs to run across multiple platforms such as Windows, Linux, and macOS. Those operating systems are supported as development workstations. Visual Studio can be used on Windows with the new limited version on the macOS. And VS Code can be used on Windows, Linux, and macOS. The command line can be used on all supported platforms. And the second point is related to when microservices are being used along with .NET Core. Microservices are a form of service-oriented architecture. and they can also be considered as software applications comprised of small modular business services. Each service run in as a unique process, and we can deploy them independently, and microservices can be created in different programming applications. .NET Core allows a mixture of technologies, and it is lightweight and can be minimized for each microservice. It is scalable as new microservices are added. And the third point is when it comes to using Docker containers along with microservices. Containers and microservice architecture are often used together because it is lightweight and modular. .NET Core works well with containers. Server apps can be deployed cross-platform to Docker containers. If we consider about the .NET full framework, .NET framework can be used for containers. That's true, but the image size can be larger. Therefore, we can simply say that .NET Core is born to live in a container. And the fourth point is high performance and scalable system needs. If you have a high performance and scalable system need, .NET Core is recommended because Microsoft recommends running .NET Core with ASP.NET Core for the best performance and scaling. This becomes important when hundreds of microservices are used together. A lower number of servers and virtual machines should be needed. And it will be beneficial. The efficiency and scalability gained could translate to a better user experience in addition to cost savings. And if we run multiple .NET versions side by side, in that case, to install applications with dependencies on different versions of .NET framework, developers need to use .NET Core. Multiple services can be run on the same server with .NET different versions when we use .NET Core. That is also possible. And when it comes to the CLI control, sorry, if you want to experience the CLI control, some developers prefer working in lightweight editors and command line control. In that case, .NET Core has a CLI for all supported platforms. It requires minimum installation on production machines, and still there is an opportunity to switch to an IDE as Visual Studio IDE. And so we have discussed about the advantages of .NET Core when it comes to microservice development. But there are some other scenarios where .NET Core is not recommended during the microservice development. So in that scenarios, using .NET Framework is recommended over .NET Core. Or in other words, well, not to use .NET Core. So we'll have a look at them as well. The first one is when it comes to Windows client applications using Windows Forms and WPF. Windows Forms and WPF applications are not supported because we still have to use Mono to make a .NET desktop application for macOS. And also, if our application is a user interface-centric web application, in that case, .NET Framework is better to be used now until .NET Core catches up. And also, the third point is, if we already have a pre-configured environment and systems, when we already have an existing team with .NET expertise knowledge and building a production-ready software, we are already working on an existing app and extending its functionality. In that case, .NET full framework is recommended. And also the fourth point is stable version for an immediate need to build and deploy. .NET framework has been around since 2001. So comparing to .NET full framework, .NET Core is just like a baby. So if you have close release schedules and if you have very tight deadlines and don't have enough time for learning new technology, in that case, continuing your work with the full framework is recommended because .NET Core has a learning curve. So, and if you don't want to deal with continuous upgrades and changes, then also .NET full framework is recommended. When it comes to the third-party dependencies, if there are very tight dependencies related to with some third-party libraries, then .NET framework is recommended because that particular third-party library might not have enough adequate support for .NET Core. So those are the scenarios where not to use .NET Core. So so far we discussed about the advantages of .NET Core and the scenarios where .NET Core is not recommended during microservice development. Let's quickly move into EF Core. We can consider EF Core as the new version of Entity Framework after EF6. It is an open source, lightweight, extensible, and cross-platform version of Entity Framework data access technology. EF Core is intended to be used with .NET Core applications. However, we can use it with standard .NET framework-based applications. In that case, the framework version should be 4.5 or above. EF Core supports two development approaches, the code-first approach and the DB-first approach. But EF Core mainly targets the code-first approach and it provides a little support for the DB-first approach because the visual designer or wizards of DB model are not supported here. And these are some of the common features of EF Core and Entity Framework 6. Some of them are DB context, DB set, data model, querying with link to entities, save changes, migrations, and so on. And EF Core itself has an exclusive set of features and they are listed like this. And I won't explain them one by one. I'll just go through them. Batch insertion, update and delete operations, then IOC, unique constraints, shadow properties, and so on. Moreover, we have alternate keys, global query filter, field mapping, DB context pooling, and so on. So that's it about EF Core. And summarizing what we have discussed so far, we just tried to have an explanation of microservice architecture and we discussed about the benefits or the advantages of microservice architecture or monolithic architecture. And then we moved into developing microservices with .NET Core and we went through the advantages of .NET Core and also the scenarios where not to use .NET Core. And then we had summarized the explanation about EF Core. And now it's time to start the demo. For that, I'll go to Visual Studio. As for the demo, I have developed for the demo. I have developed a sample shipping service which handles the shipments and it handles REST API requests such as get, post, delete, patch, put, and so on. And first, let me start with the architecture of the microservice. And here we have the API API project, which is the startup project. And as the controllers, I have got this shipment controller, and then with from the shipment controller, we are calling the relevant methods in the other layers. And for an example, let me get this get method, and here by providing the shipment ID we can get all the details related to the particular shipment, and all these API requests are or API endpoints are implemented as async requests. And for an instance, if we pick this get request, here we have the shipment query service. And if we try to go to the definition, the query service is implemented in domain services layer. And in the domain services, if we check here, yeah. In the domain services, we have this is the domain layer, and here we have two main in the domain services interfaces. And under that project, we have couple of interfaces for handling query services and command services. Query services is this is the one for query services related interface. Query services is uh, created with the purpose of doing the database reading related functionalities, for an instance, get by ID, listing, and so on. And then command service interface is used with the purpose of doing database write operations. As an example, creating records, updating entities, doing patch operations, delete operations, and so on. So for database writing purposes, we use command service async, whereas for database reading purposes, we use query service async. So those are the interfaces, and those interfaces will be implemented in all the services in general. That means here since I have only one controller for the demo purposes, this is the shipment controller, and shipment controller has shipment query service, and shipment query service is using this interface, shipment query iQuery service interface. And assume there are some other controllers, let's say product controller, then inventory controller, and so on. Likewise, if there are any different controllers, they also can implement the same interface when it comes to database reading purposes. And if we continue with the get method, get async, if we go to the implementation of the get method, the get async, this is the implementation. From the domain services layer, we'll be communicating to the repository layer. So repository layer, similar to this interface-based design, here also in the repository layer also, this is the repository layer, shipping service data dot interfaces, data layer. Here we have the repositories. Inside the data layer, we have the repositories. Here also we have couple of interfaces for the repositories. They are I-read-only repository and I-write-only repository. Similar to the earlier explanation, here also these repository interfaces are created based on the purpose of database writing and reading distinguishing. So I-read-only repository is responsible for database reading operations, get operations, and write-only repository is responsible for post, put, patch, and delete related operations. So I'll start with the shipment query service async. Inside the shipment query service async, we are calling the read-only repository. And if we check the definition, it refers to the interface of I-read-only repository. And if we go inside the implementation, this is the implementation. So shipment for the when we are when we need to get one shipment, we are passing the key, the shipment ID, which is the primary key, and using that primary key, we are doing the filtering here inside the shipment repository layer. So here we have used EF, EF4, and this is our DB context. And we have got two tables, the shipment table and product table. And the shipment table is the main table, whereas the shipment ID will be used as a foreign key in the product table. So all the DB context relationship definitions are listed here with the relevant constraints and so on. And if I go to my repository again, yeah, this is my get by ID related request. So we are from the database DB context shipment list, we are querying the shipments, and here you can see we are getting the details along with the corresponding product details as well. So we have included the product details attached to a particular shipment. So then the shipment detail, the shipment entity which we are retrieving is mapped to a shipment DTO object, and that particular shipment DTO object is returned to the front layers, and finally it will be returned as a JSON response. And if we check this shipment DTO, we can see each shipment can have a list of products, and here we have shipment ID, name, country, shipment date, and so on. And if we check from the database, this is my database, and here we have the shipment table, whereas currently I have included some data, I have added some data, and this is my product table. Here in this product table, we have the product ID as primary key, and shipment ID is used as the foreign key, and shipment details are listed like this. And if we try to run this microservice, before that, let's go to the Unity config. Sorry, I forgot to mention about using AutoMapper. Yeah, I have used AutoMapper, and we have some mapping configurations as well. Yeah, these are the mappings that I have used, and then yeah, here in the launch settings JSON, I have used my application URL here, and the application related other details are listed here. And okay, if I try to run this one, initially the listing, if we run this, initially the list request is called here, and all the shipment details are listed here. And if we try to get only one item for an instance, let me give 7 as the shipment ID. We are getting the details of that shipment. So this is the shipment ID 7, and it doesn't have any products. So if we try to double check it from here, yeah, you can see shipment ID 7 doesn't have any products. So if we try to get shipment details with the product which includes some product details, let's try 8, shipment ID 8. Yeah, here we can see shipment ID 8 is here with some product details as well. Products are listed along with that, and we are getting it as the JSON response. And if we again go to the controller, our shipment controller, okay, and so this is these are the requests that we have tried get by ID. We tried it with products and without products, and then we tried the list which is set configured as the default one, and then those two are related to database reading, and then we'll try a post one, and this is about creating a shipment record, and in that case from the body request body we are passing a shipment details type object, and with that particular object will be used for creating the record. And if we go to the implementation directly, here this is we can simply I have used database transactions, and inside the transaction scope we are doing the record adding insertion. This entity is mapped using the auto mapper. I have mapped it into the shipment entity. This DTO is mapped to shipment type object, and it is added to the shipment. And then we are saving the DB context changes, and then we are committing our transaction. In case if there is an exception, we'll be rolling back our transactions, and we are throwing the exception. So that is how we have implemented the database shipment creation. And if we try to try adding a new shipment object, I'll go to Postman, and I'll open my post, and now we are going to insert a new shipment record. Let me change it to R10. So the shipment name is R10 and country is set as Russia, and there are some products as well. And if we send this one, we are getting the response as true, and the new record is created. So if we check from the database shipment details, you can see the new record is created called shipment R10, and the shipment ID is 1018. So if we try from the here, we'll try querying that one. Get by ID, the shipment ID 1018. So this is the newly added record, and it already has some products as well, because we along with the JSON object we sent the products as well. If we check the, sorry, I forgot to show the request body, and yeah, here we already have attached some product details. So along with creating a new shipment record, some products are also added, one product. So if we double check it from the product table, it is here, one record is added on behalf of our shipment ID 1018. And now I am ready to change that same record that I have added. For that, I'll do a put request. So here the shipment ID is 1018, and the shipment name is R10, and I'll mark it as edited, and I'll perform this. This is the request body for the put request, and now I'll perform this put request. I'll send it. It is sent true, and if we run it here, yeah, you can see that record has been updated. It's now it's shipment R10, and edited is here because we recently updated this record. In the meantime, we can check it here as well. If we query it again, we are supposed to get the new details. You can see it shipment R10 edited. And moving on with the controller will check the put request. This is the put operation that I recently tried out. If we check the update async, go to implementation, and here we are using write only shipment repository, as I explained earlier, for the DB write operations, and put async. We go for the implementation here. Here also similar to database records shipment create operation. For shipment updating also I am using transactions, and with the transaction scope we are trying to update the record and update the DB context, and then saving changes asynchronously, and the wait operation is used here. And once the saving is completed, we are committing the transaction. Or else, if there are any issues, will be roll back in the transaction, rolling back the transaction, and throwing the exception. And this is about the put operation. And if we try to fetch the records, fetch a shipment record, here I'm using iPatch request collection, and if we go to patches in, here patch collection is the patch request collection is passed as parameters, input parameters, along with the primary key ID, and this particular patch collection is used in the patch operation. And once the patch, here also for database patching, we are using the transactions similarly, and we'll be updating the record with the patch collection. And let's try a patch request as well. For that, I'll use Postman, and I'll go to a sample patch request, and now we'll here for the patch request when we are in the body, when we are sending the patch request collection, we are sending a JSON object like this. Here we have three properties: operation, value, and path. And operation refers to the action that we are planning to do. So we are trying to replace a particular value. So we are passing the operation as replace. And the value is used as shipment. Here I'll change it to R10. And because I'm trying to replace the shipment name, so I'll mark it as shipment R2 patched now. And path is name. Path refers to the corresponding column name. Since I'm trying to change the name, I have set the path as name. And value is shipment R10 patched now. So let me send this. Sorry. It's giving an exception. Let me try it later. Sorry, it's my mistake because I have used the wrong primary key, because it says value cannot be null. Here we don't have, if I double check it from here, we don't have no such record on behalf of the primary key 1017. So I have used the wrong primary key here. So I'll use the correct primary key and try it again. It should be 1018, not 1017. Yeah, now we are getting the correct response as true. And if we if we double check it here, yeah, now we can see the new name is here, shipment R10 patched now. And if we double check it from here, you can see the newly updated, the newly patched record is here. On behalf of name, the new update is here. And let's try deleting the record as well. if I try to delete this record, 1018, it is failing. So let's see why it is failing. Yeah, it is failing because the reason is straight away I'm trying to delete this straight away I'm trying to delete this record, but in my delete operations I haven't configured deleting the products related to that particular shipment entity. Since we have some dependencies related to some foreign key dependencies, it is not allowing me to delete it because my delete operation straight away deletes this record disregarding to the foreign key dependencies, foreign key relationships. So that is the issue. That is why, according to my current implementation, the delete operation is failing. So if we check it from the delete async, you can see I am only removing the ship. I'm only trying to remove my shipment record. That's all. That's why it's failing. So as at now, let me manually delete the product attached to it. Then it should allow me to delete it. Let me delete the product. There, the shipment ID is 1080. Now we don't have this shipment record, and sorry, we don't have this product record. We only have the shipment record. So let's try deleting it again. Yeah, now it deletes the record correctly because there are no foreign key dependencies. And if we double check it here, that particular record is no longer available. And further, if we do the get operation for a particular record, and now if we try to query again for our already deleted data, it doesn't give any response because there is no such entity for the given primary key. So, and also, yeah, that's about the operations related to the microservice that I have implemented here, the shipment controller. And if we check from the composition rule, this is the place, sorry, this is the one which I missed earlier. This is the place where I have configured my DI related configurations, dependency injection related configurations. So I'm my interfaces and my interfaces which I have implemented with the shipment DTO, and they are like I query services in I command services in type of shipment DTO, and then my concrete service classes, and then my interface repositories type of shipment DTO, and my concrete repositories are included, configured here as scoped type, and also my DB context is configured here, and with the connection string details, and in the app settings JSON, I have added my shipment DB context, DB connection string for my DB context, shipping DB, and yeah, and if we consider these interfaces, I have defined these interfaces in a way where we can define an exact where we can define any preferred type of entities, and if your application don't have any complicated objects, and if your application have, if we consider according to the database schema, if your database schema doesn't have any complicated complex objects, if you are directly referring to your simple tables in a simpler way, you can go with this approach. So that's about the demo. And yeah, if you have any questions, please raise.
Hi Sugandhi, I think I have a questions on this one. So
Okay.
this demo, is it available for anybody to download, like this demo in a GitHub location? You can just share it with the people. They can have a look at it, how it works, and so if you can just, yeah.
Yeah, Fikri, for the time being, it is not added to
Okay.
GitHub. It is added to our internal repository in Embla.
So is it like
And
so your internal stuff, office? Is it your office stuff, or just is it like you created it for just this demo for our?
I have created it for this demo for this
Okay.
session, but right now it is there in our internal
It's
repository.
okay.
But if there is a specific location that you are using,
No, I think
I'll
you can just
upload
share
it.
it with your personal GitHub, and
GitHub.
then you can
Okay,
give us
sure.
the link, and we can share with the
Yeah,
audience.
yeah, sure. We'll
Yeah,
do it.
yeah.
Exactly. Yeah.
I think it's that's it. Thank you very much, Sugandhi, for your time and this valuable things you have said. So I think we can take it over from now for the next session. Thank you very much.
Okay.
Okay.
Thank you very much, Fikri and Hansamali, for giving me the opportunity to do this session. Thanks again.
Thanks. Okay.
Okay, thank you.
Okay. Now,
Okay, so we'll go to the second session.
yes, I think
So,
we'll the next
so
one,
we
right?
have so we have Fikri as the second speaker. So he's going to talk about Power Apps, micro front end with Power Apps. He will be doing a demonstration on that. Uh, I think you all know about Fikri. Fikri, he's a MVP in developer technologies for like 15 years, the oldest MVP in Sri Lanka,
Not all
and
this.
and he's the founder of PP Charity. Okay, Fikri, you can start.
Yeah. Thank you very much. So let's get started on this one. How do we? What is my? So this focus on this session is like how to create a front end, a micro front end. So don't misunderstand this micro front ends. This is not. I'm talking about micro front ends like we are using with single page applications, which is like if you have this front ends, different technologies. Our same team working on micro front ends. Like one team is working on what do you call React.js, one team is working on Angular, one team is working on Vue.js. Not sort of micro front end today I'm talking about. So this one micro front end means it's a small front end, a mobile application or maybe a tablet application for your existing enterprise application. For example, if you look at like this. So before that, I'll just introduce myself and I'll share my screen. Share screen. Share screen. Yeah. Now I have shared my screen. This is me. So I'm very lazy on PowerPoint, Smile, and I'm an MVP for developer technologies. Developer technologies for 15 years. So that's me, and I have a small startup called Peach IT. So we are develop on basically we look at on Power Apps, Power all Office 365 development, Azure and .NET development on this thing. So that's our thing. And then today I'm going to talk about micro front end using Power Apps. So I'm going to use Power Apps as your small front end. So imagine you have a huge enterprise or maybe ERP system which has lots of information like invoicing, customers, all those things are there, right? So sometimes when you just go outside, mainly we are looking at people who go outside on the field, a salesperson, or maybe not even outside, like a receptionist in your front desk. So people always call the company, maybe your vendors or maybe your suppliers. They will call you and ask about, okay, this I have this invoice. Can you just let me know what happened to my invoice? So most of the people just go through their ERP systems and they go inside and then just search for this invoice and they look for the information and come back. So it might take time. Sometimes they might not have login. Sometimes it's like a process. You have to log into these things and just come back. So my idea is like, why don't you just build small interfaces like front ends for these sort of small questions people ask? For example, what happened to my invoice? Or maybe if a salesperson go outside, he goes there and just get an invoice and maybe sign that invoice and then complete it and send back to the database, and it updates the ERP system. So that's my plan how to do this. So my architecture will be look like this. I'm just open my blackboard here. Let me open the blackboard and you will see it. This is my architecture. So I have Azure here on this area, right? This is Azure. I'm going to use Azure here. So this is Azure, and I will have small microservices. I think that the previous session we have talked about microservices. These will be small services, right? Small parts of like code that talk to each other, right? Talk to each other. So I'm using these services. I'm going to use for these services called an Azure function. Everything will be an Azure functions here. Another Azure function. For example, if somebody asks, give me an invoice, it will be take care of this Azure function, and give me all the invoices. It will take care of this and filter my invoices, and it will take care of that. And then, or maybe create an invoice. So it will take care of this function. So you might have three functions individually. These things are functions like isolated. These functions, it's a there, and you can use these functions. And these are serverless. Serverless means this term is like bit what do you call, it's bit like misleading, because doesn't it have a server, or maybe doesn't it have like a backend system? No, the main thing about this serverless means you have a server, but these items we will be using for, like, for example, you will be paid for, like, for the processing we used. So if you're not using this function, you are not charged. If you're using this function, you get just charged, right? So these serverless functions have created three functions here, the one and this one and this one. So it will talk to a database here. It will be an Azure SQL database, a DB, a SQL DB, to get this information, right? So these information will be picked up through this database. So this database might be populating from an ERP system, right? Or maybe whatever the ERP system you have. I have just mimicked this thing. Now my Power App will be using. So I will have a Power App. It will be a mobile-based Power App talking to Azure API management. It will talk into Azure API management, and Azure API management will look through these functions. So for example, if I ask, give me an invoice, and then it look at this function, it will execute this function, get the data back here, and then go to the mobile application. So I am going to use Power Apps for this one. Why Power Apps? That's the next question. Why we have to use Power Apps, right? Power Apps is like, just like we call it as no code, low code solution. So you don't have to write any code or nothing. For example, you can just build these front ends using maybe let me say, just you can build these front ends using what you call any other mobile application languages like Kotlin or Swift or Xamarin or maybe React Native, Flutter. It doesn't matter, right? So then you have to build this application and you have to put it into a app store, and then you have to download from it. So those sort of things, there'll be like a development cycle, development project. But if you use Power Apps, it will straight away If you have Power Apps downloaded on your mobile application, you have an Office 365 account, and then app is shared with you, straight away you can use this application. And the development time, it's very low. So for example, it will take my, like for this application, it took me around 2 days. I'm going to demo that application right now. It took me like 2 days to build this application entirely, the 3 Azure functions, and design the database, and create the Azure API management, and create the front end. So normally when an enterprise or maybe ERP, you might have all these things, but only thing you have to do is like create the Power App. So it kind of like a developer based things as well to create the functions. So why Azure functions are used? Because it's easy to create functions quickly. So for example, you might have an ERP system, but there will be an API exposed to you guys, but still you might have to use these functions, like for example, these functions or these APIs quickly, and then you can just build a function straightforward, and then you connect to this database and get the information out using API management. So that's what I'm trying to do. I just let me share my Visual Studio. Think the first point I'm going to show you the functions. Graph tutorial, do function. Where is it? Let me create the invoicing app. Yeah, this is the one. So I'm going to open that application. So wait for a second. Yeah, now you have your application here. So you have your application. If you look at this side, you have an Azure function app on this area. If you look at this one, you have this Azure function app. This is your Azure function app, and this is the service I have used for like this is kind of the shared service I'm using for accessing my stuff. Like for example, if you look at this service, it's a simple service. Yeah, it's a simple service. It has one model, like an invoice CS, and it has invoice service to pick up these things. Like let me have a look at it. If you look at this one, it has an invoice ID create. So you can mock this part. For example, you might have a but because you have from ERP, you might have this invoice information, lots of information, right? So you can mock this part like a part of that invoice you need. Whatever the information you need, you can just create a model here. So for now, I need my invoice ID, and I need the create a date. I need like let me increase a bit. I need date time, the created date, due date, amount, the customer, and whether it is paid or not. So these are the information I need from my invoice, right? And I have built a small service which will be talking to the database. So for example, this service will be talking into the database I'm using. If you look at this one, let me open the dependencies. I will look at the frameworks or the packages I'm using. If you look at here, so this part, oops, not that one. So this one, see, I'm using Dapper. So Dapper is kind of like a lightweight micro ERM, ORM. Sorry, it will be a micro ORM which will be used to access the database quickly, and then you can give your models, and then you can just use your select queries like this. Like for example, if you look at this method, I'll just go through this method. Yeah, in the screen, if you look at this method, this part of the method, right? So it will picking up all the invoices from my database. It will create a connection string to the database. It will say, okay, using SQL connection, and then get my DB, and then a query will be select all invoices from the database table, invoices table. It will pick up everything. I'm going to create a query here, right? If you look at this one, I'm going to create a query here saying get me all the invoices. That's the first line of the code I'm picking up. Now next step is like this part. This part I will explain later. This part I'm going to getting a parameter which is the same parameter here. See, the same thing, company and company. I'm getting a parameter from here saying get the company filter, maybe customer, filter from the customer. That's my main purpose. I'm going to filter it and say check whether it is null or empty. Why I'm checking this null or empty means, so I'm checking whether if nobody's enter a query string which is equal to company, and then if nothing there, lists all the invoices, else invoice create this query where customer like from company, maybe start from A, B, C, whatever it is the type, and start picks up the invoices, and then it will be query from the database and make it a to list. Or unless I call only for this point, until you call this to list, it won't do a database call. So make sure this is unless you, if you type to list only, it will go to the database and do the database call. Else it from this to end, from this area, it will just pick, it will create only your query string, whatever the query you are going to build. This is a very good practice because you can just I can do this db query invoice to list and pick up all the invoice and then filter from it. It won't work because it will give you a performance hit. So you have to do the database call with everything, the whatever the query you have bundled with, right? So that's the main part you have to do. That's my picking up all the invoices. And the next part, the next stuff, yeah, it will pick up only one invoice. So it's straightforward. I'm going to pass the ID here. So let me just say I'm going to pass the ID here and then pass it to, oops, from here, right? Invoice ID, where it's coming from. So it's coming from, I'm going to pass the invoice ID. So, and then I've created a parameter here and then pass that for this thing. So this parameter will be saying invoice ID. It will be a new object, pass to this one and create the query and get one. So this is a very important part, to create just one query, a single value. So it will pick up one invoice here. That's the second part. The third one is creating the invoice. Let me just see here. Yeah. So picking up the invoice, the entire code, right? The entire code will be picking up the invoice, saying same thing, create my invoice, and then the invoice object here. See, the invoice object, I'm going to create the model I have created to pick up that model here and then pass to SQL, right? That's how it works. So we have just three small functions I've created. This will be the under the service. Next thing is, how do you create this function? So let me go back to my function app and open it. I have two functions. See, actually, yeah, I have two functions. This one is the get invoice function. So look at this one. So this is how you create. So I'll start Visual Studio. This is how you start. This is the demo I'm going to do. This is how you start. You go back and open Visual Studio. I'm going to say create new project. So you create the function. You create new project and then scroll down Azure Functions. You have these Azure Functions here and click Next and select wherever the thing you want to just store it and then say Demo Function App. So this will create a function application. So within this application, you can just create lots of functions. Function 1, function 2, function 3. All of these will just small microservices. So yeah, small microservices, and then you can use these things differently. Like for example, whatever the function, it will be act alone, and then you can just create your own data source for that. You just get the information. Like I'll just create. So there is a question saying, does Dapper lightweight than EF Core, or Dapper seems configuration is pretty much easier than EF Core? Is it correct? There are two questions, right? Is Dapper lightweight? It's not. It's kind of normally we call it, this is a micro ORM, so it's not like heavy as EF Core. So for example, you can write direct SQLs to these things. So when you use Entity Framework Core, all your link queries will be translated into SQL queries and then send back to the server. But here you can just act directly. So the performance wise, Dapper is good, right? And then the configuration is easier because most of these guys it feels like easier because most of these guys are coming from edu.net. So we used to write queries, we get information and we get back out information, right? So it depends on your need. So EFCO is like, now if you use EFCO like sensibly, like for example, you just don't create like suddenly you don't hit tool list will be picking up all the, when you just tell EFCO to access the database until you can just build the query like I did here. So you can do that. You can just use iQueryable interface to create your own queries, and then finally call entity framework, and then to whatever the tool list or whatever the maybe I whatever the thing you need, or maybe to array to list, whatever the list you're gonna I collection you're gonna use, right? Make sure that you use iQueryable and then create the query first, and then you don't get the performances. Like for example, just like productivity wise, I suggest entity framework is very easy. You just create all your tables and all your entities, and then it will be code first stuff, right? So from data end, you need the database. It's kind of a database first. You create the database, model the database, and you can just create. You can just use SQL queries to access. I think got your answer from that one. I'll continue on my demo. So demo function app and create. Now here you have options. For me, I'm using HTTP trigger because my function should be accessed through HTTP, not from a trigger. Trigger means whatever a database entry is there. So maybe like maybe if there's a database, or maybe if there's a file is created, those things can be HTTP trigger. So my expected needs to create, so it should be accessed through HTTP and it should be act like a REST API. That's my plan. So this is why I'm going to use HTTP trigger. But make sure if you look at this HTTP trigger, I have selected .NET 5 as the my framework. But if you select .NET Core 3 LTS, you will get an extra one. See, an extra here saying HTTP trigger with Open API. So this is Open API with documentation. Like most probably it will create Open API documentation. You can easily use this functions, right, for something else. Maybe you can just directly use for an other API management. Give this option, or maybe it will. You can create use Swagger kind of documentation for create a source code, like to accessing source generators. So, but for because I'm using .NET 5, I'm going to use just a HTTP trigger, and I'm going to create it. When you create at the first time, your function will look like this, right? Yeah, is my function. It's loading. Yes. At the first time, it will look like this. So your function, it will work locally. So don't worry because why it's red, because it's just currently restoring all the dependencies required. That's why it was red. Now it's okay, right? If you look at this function, this is the function. This will be the function. It's like a method of your application. It's most probably you will see it's a static function. See, right? Function one, function one. So you can rename this function one. You can just normally what I do is like I'm gonna rename it from the file. So make sure each function get a file. It's better to separate your functions. Maybe get functions will be on one. So for example, get invoice and get invoices, or maybe get invoice from ID, filter it. All those things will be on one function. Create invoice will be another function. Update invoice will be another function. So it's better you separate your functions. And I'm going to say maybe let's say demo function. Enter. Yes, make sure you change this. Yes, now it changed into demo function. This will be the class name. So it doesn't affect on the function name. The function should be, I'm going to create demo get function. This will be your function actual, will be displayed here, right? This is the first one. And if you look at here, so it says HTTP response data. See, this response data is new to .NET 5, and before that it was iAction result. Like on your normal web API, it was on iAction result. You can just return the JSON stuff, but it says here HTTP response data. You something you might need some extra work to do these things, right? And it will be this part of the function. Let me show this part. This part will be how to trigger this function, and then this will be the security. So it's the security will be authorization level authorized for the function. So that will be function, this function level authorization, right? And then parameters. So look at this part. And then another example here. So this area. So this means this function can be accessed through get method or post method. Two different things. Get or post. It's up to you. So make sure you don't mix these things. That's not a good practice. Make sure you don't mix these things. Use these things. One function will be get. If you want a post function, create another one. Right? So don't mix those things. So it will get or post. I'm going to delete this part. It should be only get. Next part will be the request data, your request, the parameter and the context of that function, right? Now we have a logger, it's automatically injected here, the iLogger. So you have this logger, you can use that logger and then get the functions, right? And logger information, this is for, and the request is going to create a response. It says HTTP status code, okay, and it will add header types, text plain. I'm going to say not text plain. Make sure maybe you are for sending JSON, you can just say JSON here, and welcome to Azure Functions, and it will just send back the function here, right? So maybe you can, or you can just create like this, not write string, create an object there. I will show my other function. Let's make sure welcome, and then it should be text plain. When you execute this function, it will be executed locally, right? Executed locally. Let's execute it. Just play it, and then you will see a window pop up. Let's see where it pops up. Starting the storage, local storage manager, and then you will see this one. See, now look at this one. If you are creating an HTTP function on this area, so this will be your function name. So demo get function, this is the function, this is the label you have given to that function. Get is saying okay, get method, and then it says a get method here. I have a get method, and this is the URL it's given to you. See the URL, this is the URL you're going to access this function. See, now it says HTTP localhost colon whatever this is API, the name you given here. So I don't like this name because it shouldn't be look like this. So you can't just change these names. For example, imagine if you are getting invoices, it should be API/invoices. If the get method is there, it's picking up all the invoices, right? If it's a post method is there, it should write an invoice. It shouldn't create an invoice new. It's the update method, it should update the invoice. If the delete method is called, it should delete. But the API/thing must be the same thing, because one thing you have to notice. So that's because you haven't given anything here. You didn't say this function, please use a route. So you didn't use a route here, then you can just put a comma inside this HTTP trigger. You can say comma, inside this one, comma, root or route. I'm going to say route should be, let's say, invoices. Now save it. Let's try back again. Now look at your function. Much more clear, much more nicer, right? Now your function looks like this. Now your endpoint is, now it looks like a nice endpoint. So localhost, whatever domain name /API/invoices. How do I access it? Simple. We just copy this one, copy, and open a thing like Postman. Let's open Postman. Yes, we have Postman here. Open Postman and create a new one. Let's open a new one. Paste this URL. It's a get method. Let's send. See, now you have this Azure Functions. Welcome to Azure Functions. See, now a REST API. You have a REST API, nice REST API. You can access. So you can just write any front end for this one. So now you got the idea, right? So next step will be how to connect this thing into Power Apps. Let's go through it. I'm gonna go back to my, or the actual one. let's stop. Let's go back and stop this, right? So let's stop this here. So you have this, let's minimize. Now you have this function. I have two functions here, two different functions, create invoice function and get invoice functions, right? So let me have a look. If you look at this one, so it's the same thing. It has a function, just one function. It says get invoices, right? Now it will be using the get method here and then a route. See, the route will be, you have your invoices route and then you have a parameter here saying ID parameter. And then if you look at this question mark, this question mark says this ID parameter is optional. So it's not a required one. That means if you didn't put the ID, it'll pick up all the invoices. If you put the ID, whatever the ID /1 or 2, then it will pick up all the whatever the ID you given. So this is how in the source code. So I have created, look at this line. This line I have changed as JSON. Here it will say JSON and then query string, and I have created, this is because this is an helper class I have used from Microsoft Query Helpers to pass the query. It gets the request.url.query. So query means if you type invoices invoices company equal something, you can pick up that thing, right? Where this comes from, it's coming from it's coming from this one. Remember that if you're using .NET 5, if you're using Azure Functions to get, it will be HTTP response data. So because it doesn't have a request method like that, so HTTP trigger. So for that one, I have used Microsoft ASP.NET Core Web Utilities. You need this one to access this query helper. Query helper will pick up this URL query. Now in this line, if you look at this line, so this is a variable, company variable, that's okay. Now I'm going to go to this line. Make sure I'll just go to next line. It will be more clear. Now look at this. So you have this variable company, which is a string, and then I'm going to pick up this query string from the helper, contains key company, because it might not have company. If it's their company, please look at for the content is company, check. That means it will be, if you have a key, it will say true. It's not, that means false. If it is true, that means the key is there, and pick up the company, whatever the query string written there, to string, else make sure it's empty. So no query string. And you create the invoices service, the service I have created. This is a shared service for all functions. If you use this function, and then now if the ID is null, there is no ID, and again the same thing. Here, if the ID is null, that means no, the ID is null, make sure serialize it and then get the invoice, whatever the invoice, and serialize it here. See, serialize it, else pick one invoice. Now I have used one function to do the two different work. If the ID is null, that means get everything, invoice, get invoice, and pass the company with the query and the value. So this is how function, and then finally write as JSON and return the response. The response I have created, this is the response. So we have created the response class here, and it is create, and then I add the headers for the response, and now this is the body and with responses. That's one. Now if you look at the create one, create invoices, it's a bit different. It's the same thing, but only different is you have a post and the route is the same, which is invoice. Now it will get here log information, that's okay, response is okay, JSON. Now look at this part. I'll just make sure you have, oops, sorry, this area. If you look at this area, see, it says the response code is this HTTP okay, and add the content type for JSON. That's okay. Now if you look at this area, the second one, let me go back this area. right? It says using stream reader. I'm going to use a stream because my payload will be in the body. Normally, if you're using APIs, you normally send this a JSON payload. The object, whatever the object you're going to send, request.body, use a stream reader and read everything to this body. And this line, this is important. If you look at this line, right, what it says, okay, now you have this body information. I know I'm going to send a body information type of this invoice. Type of this invoice, deserialize and make it as an invoice object. That means it will turn into this invoice object, and finally it will pass it to my create invoice service. See, as simple as that. This is how it works. You get it, and then it will just go inside. Finally, this line. So when you create an API, it's a very good practice. You have to tell your consumer what's happening, right? It's a very good practice. This is how do I tell it? So that means this line, I'm going to say, okay, create a response which is created. This is a very good thing. You have to tell that, because then your consumer will be knowing, okay, my the function went through, okay, and then my database item is created. Now I have got a response code called created, and then return the response, and then whatever the affected rows, write it and select the response. These are the functions you have created. Next step will be publishing this function. If you go back to Azure, let me check on Azure. I'll open my browser. Yeah, it should be here. Where is my browser? Yeah, this is my Azure. I'm inside my Azure. I have created a resource group here. It has Power Apps. Power Apps. Now these are the resources I have. I have a DB here. Look at this, my resources. Oops, sorry. Click. I have my resources, all those resources, right? So I have a API management here, and I have a database. I have this invoicing API, and then a storage account for store my Azure functions, and the server for the database, and the application plan. All those things will be available here. So you just click on the API manager. This is how you start. Like first thing, now you have your resource group. Next thing you have to do is, from your Azure, from your Visual Studio, you have to publish this. Go to Solution Explorer and then create your function app, not the service. Create the function app here. You have to select this one, right? And then click right mouse button and click publish. I already have a published. I'm going to click new, and I'm going to click Azure and then next, and create Azure app function Windows. It doesn't matter. So you just click Windows, next, and then you need credentials. You have to re-enter your credential. Let me re-enter my credentials. And sign in. Text. So wait a second, waiting for the text. Yes, you have the text. And 3, 2, 5, 1, 6, 7, verify. Now I'm inside my login, Azure login. Now it will show all the resource group. This is the resource group I have right now. So I'm going to have already a function. You can just select, and then you just select this resource group, and you can just search for something, or you can just add a new one and then create something like that. Now if you hit next, and then finally you can just publish it, your functions will be published on Azure. That's one part. That's the first thing you have to do, right? Second thing, another one you have to do is, like, if you look at here, service dependencies, and then if you look at yes, you click this plus button. I think, yeah, no, not this one. Let me check. Oh, no, you click these dots on the hosting, right? Hosting area, you click these dots here, this one, these dots, you click, and you're going to say manage Azure app service settings. This is for your connection strings. You create a SQL Server DB connection string like this. See, this is your name. You can just give a name there, and local means your local host, the server, whatever the local location. This is the remote means your Azure SQL Server database connection. So you can just put it there, and you can connect it to that database. That's your Azure remote. You save it, and that's why I can use in my service function like this. I'll just go there and then invoice services. That's why I gave this line. See, you can just say connection string environment dot get environment variable, whatever the environment variable you did. So then when you deploy it, you don't need to change because local will be picking up the local connection. If you deploy it into Azure, it will pick up the Azure connection, whatever the SQL Server DB connection. The name should be the same. That's why you have to give. Now it's picking up the connection string from the environment. You publish it. Now you are inside the Azure. Next step. Next step will be go to Azure, right? And create, you search for, like, you create a resource, whatever it is, you click and say, not a resource group. Let's go back to home, create a resource. It should be Azure API management. API management, API manage. See this one, you have to create this one first. So you click create, it will take some time, and then after creating it, you will see an API management like this. It says this is my API management. I have this one. So what I did was like now I have published my Azure functions here. So let me show that to you. I have functions, all my Azure functions will be here after I published it. Under I have two functions. So these are my functions. Yeah, this is my function. So I have create invoice and get invoice, two different functions, both are HTTP and both are enabled. Now, next step will be you click APIs, you click add API, you click add API, and then you select a blank API WebSocket, but you can just scroll down, you can just select function app. You click function app, and then you click browse. If you click this area, this icon here, and it will list your function app, all your function apps. If you click on this one, it will generate whatever necessary stuff for your function, and it will look like this after generating it. Right? You will have two functions, but look at this. Normally it will create two functions because on your function you have only two functions. On your function you have two functions here, which is creating an invoice and getting an invoice. So what I did was like first I create the get invoices one. So this is already created for me from Azure function. This import, that's created, and we have the function, the get invoices one. So what I did was like this is the get invoice everything. So the problem I created another one. The reason behind this one is like when you create that API, that parameter, the ID parameter, which is which is nullable or maybe optional, but when you pick up from Azure function, it doesn't pick up. You can't test it. It says the ID is request need. ID is like a mandatory field. That's why I create this function, get function, and then I'll just click edit, and then normally it was like this at the beginning. It was look like this. What I did was I deleted this part, this ID part, and then I deleted and then saved it. So I have created a function with function APIs invoicing. It will create get invoices. Then what I did was like I just clicked here and cloned it. Clone the other one, the first one with the ID one, and created this one. The actual one was like this. If you click ID, it will get the ID. Now you have like two different endpoints, but still we can use from the front ends. We can just create one. It says okay, invoices / ID. If you give this parameter, and it will go to this function. If you create just invoices, it will go to this method. So it doesn't matter. You create unlimited stuff, 2-3 stuff, but still it will, and consumer will be seeing only one endpoint which is get invoices will go to this one, get invoice as parameters will go to this one. Right now you have like three functions. You can just test these things. You can click and click test, and you can just say send. So you have all the data from your database. So database, you have a database here. You can just pick those things up. So the database will be on Azure. So you know that Azure database is in the backend. So if you want one invoice, you just go there and give a value, say in 3, and send. So you have that information as well. Create invoice is the same. Then you can just give the body here and then send. It will create the functions. Now you have the API is set up. Now you have your API management is set up. That's nice. Right. Next step. Next step is like exporting this function or this API into Power Apps. That's the next part. You have two different ways doing this. You can export from here and make sure one thing you have to notice is your Power Apps, the Office 365 subscription, and your Azure must be in the same tenant, right? Whatever the tenant you're using, your Office 365, all your Power Apps, all your automation, everything you should be in one tenant. Whatever the tenant you are using on Azure, that's a must. You click here, but if you don't have it, you have a separate way of doing it. I will just show that as well, right? To use this function, it should be on the same tenant, but else still you can use it other way. I will show the other way as well. So if you have two different tenants, your Azure might be on one tenant, your Office 365 may be on one tenant. So two different tenants, you can use the other way. First one, I'll show you how to use the same tenant version. If you have the same tenant version, you will see this part. See, create power connector. When you click on it, so it will display your API name. You can just say API name, and then all your environments. See, all your environments will be there, whatever the environments you have created inside Power Apps. So Power Apps environment is like an area. You define your application, you create your application, your own area. That's called an environment. Some environments are created from teams, some are just inside. When you create, it will create a connection inside Power Apps. So you go to Power Apps. So this is Power Apps. You just go to this URL. If you have Power App, make.powerapps.com. You just go there, and these are the environments you will have. Now I have my Ficris environment. This is free. Normally, if you have a work account or a school account, you can go to saying Power Apps community plan. You go there and then you click this one. Should be sign up. Yeah. Developer plan, you can just start it for free, right? So if you have a work account, then you can just start it. You can just create any application here, but you can't use it for production, but still you can play around with Power Apps. I have the same thing. It's an environment for community edition. So now next step will be, I'll go to the solutions, and I have this Power App here. This is my Power App. So if you look, this is the Power App, and then if you click on data, so because we are looking at data, and if you click at custom connectors, this one, custom connectors, you click, you will see your custom connector here. See, invoicing app function API, this is the created one. This is one way of doing it, using API management and using export function from API management if you are in the same tenant. If you are not in the same tenant, right? Imagine you are not in the same tenant. So then you can just create the same thing. You can just go here, new custom connector, and you can use create from blank, or you can just create from Azure service. So I prefer you use this create from blank. You can just say, let's say API manager 2, click continue, and then you can give a name, and then here it says HTTPS and the path. You go to your Azure. Where is my Azure? Here. Oh, not this one. You go to your API manager and click your invoicing, and this will be your settings. Click settings, and this thing will be your endpoint. See, this will be your endpoint for API manager, right? You just copy that and come back here in the custom connectors, just paste it here. So this will be your HTTP, but you can remove this HTTPS part. You have to, because you are selecting HTTPS, and then remove this part and paste it on the base URL. This is the first step. So you have a API, and then next security. Security, I'm just saying no authentication. Now I'm going to use API key. I have a key. How do I pick up that key? It's here. You just go to this key and then go to this one. See, header name will be subscription key and the parameter should be subscription key. You can just pick up this key from here. You go to test and you just call whatever the test function, and you will see this subscription key. You just copy paste here. You just copy this key and come back, and it should be header, parameter label, and then parameter name. So it should be like API key and then the parameter label, the location is header, and then name. It's header, right? You just paste it here like that. So now you have this API key, the label, whatever it is, or you can just create the parameter name. So this is how you create, and then you go back to definitions and you add each endpoint here, the location, the operation ID, whatever the name, and make sure the request, how the request looks like. For this one, the request will be looking like this. So this is how it looks like, the actual request, API management. I'll show you the final one, and go back to custom connectors. You don't save it, cancel, and click edit the existing one. So you have like the same thing. Go to security, it says API key. So now you have the API, the subscription key, and go back to the next. And you have three different things. Get invoices. If you look at get invoices, this is the summary of that, and the description, and the operation ID. Operation ID means this is the one Power Apps will be looking. This will be used as a method from Power Apps, and the request. And I have created a create one import from sample because I have created a sample. So I created the sample, click sample, and then you just say post and give the URL and paste the JSON body, whatever the body you have to create. Now this is, it looks like, right? The name, the description, all those things. You go back there. So you have the body. And if you look at get invoices, and the response will be like this. See, amount, details, all the stuff from the JSON, it will pick up. Again, you can just say import from the sample, whatever the headers, and save the body, and then it will create you these items. Make sure you get a sample from the body and ask Power Apps to do that. This is one way of doing it. Next step. Next step is go to Power Apps. I'll just show this Power App for you. So you have these items. This is now, this will be a mobile application. Let me show you how it looks like in your mobile application. First, make sure it works first. Let me check. Yeah, now this is a mobile application. You can just say, okay, maybe computer, CO, and it will search from, yeah, wait for it. See, or maybe page. I will bind it. Whatever, like if you click on these things, you have this information. Now if you just say search by ID, you can use the same thing. I'm going to say 5 and search. It will pick up the 5th one. See, now the green means it's already paid. Let me check another one which is not paid. Search. See, now this is not paid. This is picking up from the server. So these are very good things. If you want to create a new invoice, you can just create invoice date. Let me say, okay, invoice date is today, and then due date is like next month 14. Okay, and then customer, the amount will be like, oh, maybe 34. This one, and the customer will be like toy center, and it's pending, create. Now if you look at these things, now you have peach here. Let's close this. Oops, I think I didn't bind these things. Let me check again. Detail screen browse. Yeah. Now you will see the toy center, the item 10. See, now it looks like it doesn't looks, it has an error here. You can just easily edit these things. Just look at this one and go back. Let me show you how easily you can edit these things. You just select here and then You select middle, and then maybe you can just font size to 18. Let's see, 18, font size 18. Yep. Now, like, now it looks nice, right? The toy center and these things. So if you click one of these things, toy center, now you have this item. So how do you connect these things? This is the easy part. So let me go back to a new Power App. I'll go back here. Let me go to my solutions, click, and I create new app. I'm going to say a canvas app. I'm going to say it should be a mobile phone. Let me say like this, say invoice app demo, create. And skip, right? This is how you create. This is called a screen, and every screen will be represent a mobile phone, mobile application, mobile phone. So whatever the mobile size, it will be represent there. Now let me check the screen, and then you have to connect your data source. Now the API. This is how you do that. You can say add data, and under connectors, you search for these connectors. So you will see this invoicing app. See? Now you have this invoicing app API. You click it. So if you see a diamond, this is a premium connection. That means you have to pay for it. So you click and then click, it will connect. Now you have connected. Next step will be you can just insert a gallery. I'm going to insert a gallery with this vertical gallery. And I'm going to select the type. Should be like this, a title one. Right? I'm going to drag. Let me show how easy this is. Right? Select the gallery. Now this part on the data source area, see this area, to drop down to create to invoice. Now it will give an error because I just given the function, not the function name. I just gave the whatever the API name. Now if you put dot, then you will see get invoices, create invoice, get invoice, right? So which is, these are coming from this area. So remember, on your connector, custom connectors, not this one, should be this. Custom connectors, this edit, definitions, these are the names. That's why it's important. The operation ID is very important. That's why it should be a proper name. Now go back here, say dot, I'm going to say get invoices, company text. Do we need a company text? Let's say I don't need a company text for now. I'll just say everything should be there. Now close it. Let's see what happens. Now it will be just creating all those things. Now there'll be an error saying, okay, what happened here? Let me check. Now it's just not recognized. Edit. Sample heading is not there. I don't need a sample heading. This item will be represent everything. If you put dot, see now these are coming from the JSON. I'm going to say customer. See, next one. I'm going to select the next edit. It should be amount. Now the next one, the final one, edit. I'm going to say invoice date or maybe created date. See how easy it is. So you have all those things. Now if you want to filter this one, the second function you use, now this is the entire function you use. The second one you can just filter, maybe you can just say toy. See what happens. All the toys will be filters. Toy center. Now it filters. This is how easy it is. You have quickly create. Now the user interface will be take some time, but still you can just create these things. So let me show you how it works in mobile phone. I'll just sign into my thing, mobile phone. Sign in, yes, invoice tracker. I'll go to my invoice tracker here. This is my invoice app. I'm going to save file, save, and publish. Yes, publish this version. You will see that in your mobile phone. It's publishing. Let's go back. Now let's wait for it. Let's click next. Got it. Let's wait for a second. Now what I'm going to do is like I'm going to share this one to my screen from my mobile phone. Cost. Let me have a look there. Should be 1 minute. Okay, let me check that one app is there now. I will recheck my. Every time the connection is requested, should be available. I think I can't connect to my mobile phone, but if the looks will be the same. Okay, okay, okay. 1 minute. Just reconnect it. Let me check. Okay. Wait a second. Think. Connect. I think I can't connect to my laptop here. It should be available. Let me check again. Okay, for some reason it doesn't connect here, but it says connected, but it doesn't. Anyway, so you got the idea. Now you can just straight away connect these things and then create an application. So it works fine because so which is it works fine, and then it will just straight away work. And then the next step will be just you have to just go through and then publish it. If you will need a power app for your mobile device, and then you can just open that within that power mobile device, and then you can just use the thing. Let me go back here. Right. So I think you got the idea. I hope you might have any questions. Anything? Any questions, guys? Looks like no questions, right? Let me check whether why it doesn't work here.
Fikri, we have some questions.
Yeah.
Thank you very much for that superb demo on Azure Functions and Power Apps.
Thank you.
So I have some questions. Why you decided to create an app with Power Apps as a front end without going for a mobile app? You could build a mobile app with React Native or some iOS or Android native to the OS. So why did you think?
So yeah, so that question is like the main reason I have built a power app because this application will be quickly built. So these sort of things, if you have the API and you have the connections, and it just simply you can just connect to the API and build the application on the fly, like I just did. Right? You have a gallery and you can just create forms. If you want, you can just create forms. That's easily create. It's like maybe maximum within 1 week or maybe less than that, you can create a very nice application, and it will be available on your mobile device plus your tablet device, even if you're on your Windows whatever the laptop. It will be a web browser as well, you can just easily use. Those can be shared, and then security wise, so if you didn't share within your organization and then within your user, for example you have like 10 users, and then if you want to share this application with only 2 users, those two only will be have access to this application. So their login will be treated as like, and then we can just log this information, lots of things within like 1 week, like all these microservices, the micro front end, you can just, you have the API, you might have a full blown web application for your API, right? But you can create small application like this. You can separate the functionality between applications. That's why at the moment I said micro front ends. So different functionality. Sometimes some users on your office might require customer information only, like a CRM part, right? We can build a small application for them and for customer information. So for the sales guys, we can create an invoice application. For receptionist kind of thing, you can just create some sort of like a same application. You connect to the HR, leave request, all those things can be there. Somebody calls the reception, I need a request a leave, they can just mark a leave, then put the button. So see, one application you just break into small front ends using this. That's why I use Power Apps. And then best thing is you can just create it quickly. So most of the guys have Office 365 this license. Office 365 license like E1, E3, E5, they already have Power Apps. Most of the people doesn't use it. So easily you can just open this one and then create few application shared across your organization easily. That's why. So you don't need a separate mobile team to do that. Anybody who can know Excel can create these things.
Okay, so I think most of us, so the users, doesn't know or understand the value of Power Apps. So can we create a production level like high-end ERP system with Power Apps? So is this Power Apps
Hmm.
is more suitable for like creating MVP or demo for a client?
It depends. So I don't recommend creating like a full blown application like a ERP system. So that's why just you separate small parts. Whatever the requirement, you create it, right? So you can just create, or you can create automation like Power Automation. I didn't mention today. So Power Automation, you can just automate this task. So whoever the invoices or whoever doesn't pay the invoices within last 20 days, send them an email. You can use the same connector, pick up the invoices, check the date, and then send the invoice reminder emails. You can use Power Automation for that, and you can create a even like create a service bot, right? You just log in. Customers can come to your website, and then you can just type what happened to my invoice, and then what is the invoice number, sir? It will ask the question, and then invoice ID two. Just it will search the same connector. You can use the same connector and list the invoice information for them. No, it's not paid yet. Those things you can just use small items, but I don't recommend for like a full blown thing. It should be like a part of your enterprise solution. You have a web application, you might have mobile application, but you might have small items between these things, like for basically for front desk users, they can create their own application. They have the API, open Power Apps, create your application, and then use it. For that people only, yes, I recommend Power Apps, not for like a full blown enterprise solution.
Okay, so
Okay.
what about the licensing and the subscriptions?
Licensing, normally anybody who has E1, E2, E3, even this Office 365 business license, they have Power Apps. They have Power Apps. They can use SharePoint as a data source, right? So those things can be used. And if they want extra items like connecting to APIs, third-party APIs, they might require a separate license for Power Apps, which is like now they have reduced, like it's like $15 per month per user now. So you can use that part for that one as well. So it's simple rather than just going for investing a mobile application for different. It takes time to develop, but this one is like quickly. Even though within 1 hour you can just develop a small application without any user interface, right? I think we can conclude, right? today. For today, yes,
Yeah.
we have Sugandhi. Sugandhi, I'm gonna add you to the stream, and then Hansamali as well. So thank you guys for having this great session today. I'll just create like this. Yeah. So thank you guys. Thank you Sugandhi and thank you Hansamali and all the developers you just joined with us. Thank you very much. Until we meet till next time. Thanks again. Please subscribe to our channel, and then every month we bring these sort of items, developer events, and then every month. So make sure you subscribe and you get notified. Thank you. Thanks, Sugandhi, and thank you, Hansamali. And thanks, guys.
Thank you,
Bye-bye.
Vikram.
Bye.